Hello, good day. My name is Mildred Jessica Nwonye. I'm a master's student at the University of Botswana, Department of Computer Science. So I'll be taking you through my paper, which is titled Sensitivity Analysis of Coronary Heart Disease using two deep learning algorithms, CNN and RNN. Well, people find out that they have health challenges when they are forced to go to the hospital, when their body can no longer, it's functioning as it's supposed to, then they're being rushed to the hospital, or they actually take themselves to the hospital and they're being told now that they have one problem or another. But with the advancement of technologies such as IoT, Internet of Things, artificial intelligence, machine learning, models can be developed. Efficient and efficient and diagnostic model can be developed to make meaningful and accurate medical decisions, to enable physicians rather make meaningful and accurate medical decisions. The techniques that were employed or have been employed by different researchers includes the use of machine learning, deep learning, and other techniques. And some of them have proved to be successful in diagnosing heart disease, whereas the others that were not successful or that had minimal success, it's as a result of it required more validation on the data set. And when I mean validation on the data set, I mean how they were able to handle missing values, were they able to address the issue of outliers, were they able to address overfitting or feature select, did they address feature selection, which are some of the validations on the data set. Now, what are the things that I aim to achieve at the end of this research? I intend to identify an efficient algorithm for diagnosing heart disease. To do that, I'm looking at the hyperparameters of my algorithm, which one of the hyperparameters of any algorithm, its number of input layers. I want to see how relevant this this hyperparameter is on the CNN and the RNN convolutional neural network and recurrent neural network algorithms. And then I'll be conducting perturbation and sensitivity analysis on these algorithms and see how they perform based on with regards to the accuracy in actually diagnosing heart disease. Now, to be able to achieve the aforementioned objectives, there are steps or processes that needs to be done. And one of the steps is data processing. Question is, where did I get my data? How was I able to process this data to make sure that everything is fine? Patterns are found, hidden patterns are found, relationships are found in the data set. Firstly, the data set that I used is gotten from Kaggle, which is a Google platform, which is a Google platform for publicly available data. And obviously this data had missing values. I handled this by imputing missing values with mean values of features. And after that, I implemented the algorithm and I addressed the problem of overfitting. This is a major problem when it comes to machine learning and deep learning. It's the inability of your neural network to generalize on insane data or test data. And two techniques were employed, and one of such technique is feature selection. Feature selection is manually or automatically selecting features. When you do so, you're reducing the dimensionality of your data set, but still at the same time, you're improving the performance of your algorithm. And for this research, the type of feature selection that was employed is the principal component analysis, which reduces the dimensionality of the data set, but also determines which variables in your data set are important, and makes sure that no information is lost. It's used to simplify analysis. So if you want to use a feature selection whereby you want your variables to be independent, this is the type of feature selection that I employed. And after that, I perturbed the algorithms using accuracy and perturb the algorithms and data perturbation and sensitivity of these algorithms. And I evaluated. Evaluation was done. The results of the accuracy was done using confusion matrix. And confusion matrix, it describes the performance of my classification model on a set of test data for which the true values are known. And now the analysis. I've done the process of implementing my algorithms. I've addressed overfitting using feature selection and dropout layer, and now perturbation analysis. This type of analysis is whereby you're determining how your X values affect your Y values. And in this situation, my X values, the parameters that I used, are data ratio and number of epochs. Whereas sensitivity analysis, which determines how your X values affect your Y value. But now it's for a particular variable, and this variable is the number of input layers, which are called null. And now my result. So when we look at this, we can see when we're perturbing the ratio versus accuracy, the highest accuracy was attained when the data ratio was 75-25, and the number of input layers is 8, with an accuracy of 75.9. And as you see, as you're reducing the number of input layers, it doesn't affect the accuracy of the result. Rather, the accuracy of the result just goes on reducing and reducing and reducing. And when we perturbed the number of epochs versus accuracy, the highest accuracy was attained when the epoch was 200 and the input layer was 8. Its accuracy is 87.9. And still the same, as you're reducing the accuracy, there isn't much of a difference for the CNN algorithm. Now, whereas for the RNN algorithm, when I perturb the ratio versus accuracy, as I was reducing the number of input layers, the accuracy actually fluctuated. It goes up and down and up and down. And the highest accuracy was obtained when the input layer was 4. Training ratio was 80-20, and the accuracy is 89.4. As we can see in the graph, this is where the highest accuracy was attained, and this is where the lowest accuracy was attained when I perturbed ratio versus accuracy for number of input layer. And when I perturbed the epoch versus accuracy, the highest accuracy was obtained at 89.4 for number of input layers being 4, and the lowest was obtained at epoch 500 for the number of input layers being 8 and 4. So therefore, this shows that the RNN actually performed the best with an accuracy of 89.4 when the number of input layer is 4. In conclusion, it shows that for the RNN accuracy, if you are increasing the number of epochs, the number of input layers, varying the ratios and epochs, it actually helps improve the performance of the algorithm. So this parameter it's relevant for this hyperparameter rather, is relevant for this algorithm, the RNN algorithm. And future works can be done to improve this result. And one of those is using these values, the result obtained from this research, to investigate the effects of other hyperparameters, which could be your activation function, the biases, your weights, the number of neurons in your layers, hidden layers, or the number of hidden layers actually to use to see how well this hyperparameter affects the performance. And another one could be, another feature work could be actually getting data, real data now from the hospital, from actual patients who were admitted or who are still in the hospital, to really see how the analysis will be done, or to see how they perform on these algorithms in order to develop a model. So thank you very much. If you have any questions, now's the time to ask. Thank you.